in programming, there's something called, if again, this is for beginners, like we're starting from zero. If you know nothing about Python or anything, that's fine because we're starting from zero. So we already talked about variables and basic Python. So all of this is known as comments, and this right here is a variable. Now, there's an interesting concept in programming known as if-else. So there's the if statement, and then there's the else statement. So here's a basics of how that works. Let's say that I want to create a self-driving car, right? And yes, there's some very advanced deep neural networks out there for, self-driving cars. We're not going to be building that today, but we're like, if we had to do something similar to it, something very basic, just so that we can actually understand the basics of Python. Let's define a sensor, right? So what are some aspects of a self-driving car? Well, we have the sensor. So maybe the sensor of the vehicle might detect it's night, so it's automatically going to, and a lot of cars actually already have this, not just Tesla cars, but some cars have sensors where like if it's nighttime, it's automatically going to turn on the lights. If it's daylight, it's probably going to turn it off, right? All right, so let's say we have a sensor, right? So let's call this a sensor, right? It's going to be a variable. It's going to store something, some kind of value. Let's say the default value is it's detecting that it's dark, right? It's dark outside, right? So the sensor is detecting that it's dark outside. Now, we want a specific action. We want the car to, let's say, turn off the lights, but we also want it to turn on the lights. So these are two scenarios. One where the car turns on the lights, and the other one when the car turns off the lights. And it depends if it's dark or if it's bright outside, or if it's like daylight. So how would we configure this? Well, let's just use basic human language. If the sensor detects it's dark, then the action should be, I don't know, turn off the lights. Otherwise, it should. So if the sensor detects it's dark, then the action should be turn on the lights. Turn on the lights if it's dark. Otherwise, it should turn off the lights. Because what's the other alternative if it's not dark? Well, the only alternative is it's bright outside. It's daylight, right? There is no other alternative. So that's like there is no other scenario. Like that's the only alternative. It's either dark outside or it's bright outside. But it's just those two, right? So this right here is called pseudocode. Right here, I'm giving instructions to the machine, to my machine, to my computer, to like, okay, so the computer is going to receive a piece of data, right? Remember, variable is just something that stores data. It's going to receive this piece of data, and it's going to be like, okay, so what do I do with this data? Well, you're telling the machine, if the sensor detects it's dark, then the action should be this. Otherwise, the action should be this. How would this look like in code? How would this look like in Python? Well, in Python, it would be essentially this. So remember, our sensor, we're setting our sensor to detect dark right now. That's the default detection, let's say. If sensor is equal to dark. Now, why did I use a double equal sign right here? This single equal sign is just to assign the value to the variable, right? We're just storing this data inside this variable, right? Here, we're not storing anything. We're just comparing what we're saying. We're just comparing the value with what's actually in the variable, right? We're saying that there might be something called dark inside this container called sensor. So Python is going to check. Okay, it's going to open up the container, right? It's going to check the container and it's going to see what is actually stored in this container. It's going to be like, oh, okay, interesting. So dark is actually stored in sensor. What does that mean? It means that dark is the same as dark. So they're equal to each other. That's what Python is essentially doing behind the scenes. So if sensor equals dark, so if sensor is dark, what do we want it to do? We put in a colon so that basically Python automatically indents, right? This is called indentation. Indentation is very important in Python. We'll talk about that later. What do we want it to do? Well, we want it to turn on the light, sorry. So let's use a print function, right? We already talked about the print function in our first videos. Let's just print out turn on the lights, right? Otherwise, right, this otherwise is going to be represented by the else statement. And my computer's about to die. Great. This always happens. Else, we don't have to type anything else, right? We don't have to say, like, else sensor equal, no. Because it's only two scenarios. Either it's dark outside or it's bright outside. So what is the other alternative? Well, the other alternative is that it has to be bright outside, right? So we don't have to specify that. We don't have to say if. We don't have to say, like, if, otherwise, you know, sensor is dark. No, we don't have to do any of that because we already know the other alternative is already going to be light. So else print turn off the lights. So if the sensor detects that it's dark outside, it wants you want to turn on the lights. Otherwise, turn off the lights, right? So let's just run this. Well, it's going to say turn on the lights because the sensor right here is actually dark. If we change this to light, or yeah, it's bright outside or whatever, then it's actually going to turn off the lights. So this is what you call an if-else statement, right? So if it's saying that, you're telling the computer, if this is true about our variable, then do this. Otherwise, do this. That's what essentially you're telling the computer. The computer is detecting your variable and it's like, okay, if this happens, if this is true about our data, then do this. Otherwise, do this. So that's the if-else statement. Now, what the heck does this have to do with AI? Well, this is the essence. Again, if you have zero coding experience, again, I'm trying to teach programming as I teach AI, basically. This is the essence behind AI doing stuff, behind AI's logic or decision making, right? We're talking about a very important aspect of AI, which is agency. Agency. We've all heard about AI agents, right? AI agents, agentic AI. But how does that actually work, right? This is why we're diving into the very basics. All right, so that's essentially how if-else statements work. It's pretty simple. Here's another thing about if-else statements that is also important. So, like, let's suppose that, like, light is not the only, like, let's suppose that the sensor is not detecting whether if it's like, let's say it's not dark or light. Let's suppose, like, we're detecting if an object in front of us. So, like, if it detects a person, then we want our sensor to, actually, let me just start anew. By the way, you can undo right here in Jupyter Notebook. You can also press Control Z. So you just press Control Z. There we go. Run that code block. All right, copy, paste. All right, let's try something new in this code cell. Let's suppose that our sensor detects a person. If the sensor detects a person, we want, so let the car, so if the sensor detects a person in front, then we want to let the car, speed up. No, I'm just kidding. We want the car to brake, right? We want the car to stop. So if the sensor detects a person in front, let the car stop. Otherwise, now here's the thing. Otherwise, what? What do we want the car to do? If there is no person in front of us, what do we want the car to do? We want the car to just continue. We want the car to speed up. Do we want it to slow down? Well, if there's only one possibility or one alternative, then all we have to do is put in else. Else, do whatever else that it needs to do, right? But let's suppose that we have multiple other scenarios, right? Let's suppose that, let's be a bit more specific. So if the sensor detects there's a person, maybe 50 meters ahead, then let the car slow down. What about for a scenario where the person is 25 meters ahead? Well, how do I define that over here, right? If it's if the person is like, actually, let's say that let's actually be more specific. Person is 50 meters ahead. Let the car slow down by, let's say, 5 miles per hour, let's say. But what about by how much should the car slow down if we're like, I don't know, 100 meters ahead? So how would we define that? Well, how would we write that down? Well, we would probably have to do if sensor is person, it detects that the person is maybe 25 meters ahead, actually, right? I'm just making stuff up as I go. 25 meters ahead. Well, then, what do we want to happen? Let the car slow down by maybe 10 miles per hour, right? We want it to slow down at a much faster rate before we actually hit the person. Okay, so how do we actually connect these two? Well, first it's going to check if this is true. If this is not true, then it's going to execute this guy. So let's just remove this this else right here. So what we have to do is we have to write if else. Oh, sorry. Well, we'll have to write elif, sorry. Elif. Elif. So elif. So basically elif is just else if. So if this is true, great, then slow down by 5 miles per hour. Otherwise, if this is true, then slow down by 10 miles per hour. And then we could continue doing this. We could continue making elif statements. Elif, you know, the person is 15 meters ahead, right? We can continue doing this, so on and so forth. Like we could start creating a whole bunch of elif scenarios. We could like cover a whole bunch of like elif scenarios if we want, right? So we can just like continue making scenarios, making a whole, like, if we wanted to, we could probably like code in all possible scenarios that the AI, quote unquote, has to take into account. Of course, that's not very efficient. We have a lot more control, yes. We have a lot more control, but it's not very efficient. So like, let's just continue this just for the sake of illustration. Let's say 10 meters ahead, right? And then 5 meters ahead. I don't know, 3 meters ahead. I don't know. I'm just making stuff up. Then let the car slow down by, actually I need to change this right here. Slow down by, so if it's 50 meters ahead, I'm slowing down by 5. Oh yeah, actually, so slow down by 10, maybe slow down by 15. Let's say slow down by 25, and then actually slow down by, shoot, I don't know, 35 or 30, whatever. Actually, no, here, we're probably supposed to stop. Let's not actually slow down anymore. Let's actually stop. So let the car stop, right? Or halt, whatever you want to call it, or brake. So these are all, let's suppose that these are all the scenarios. Obviously, you could think of a whole bunch of other scenarios. And you'll probably end up having a huge list of else statements, of if else statements. So basically, what happened here? Oh, my bad. So basically, the sensor, let's suppose that the sensor detects that the person is 50 meters ahead. Then it's going to slow down the car by 5 miles per hour. Let's change that to that the person, let's say that the person is 10 meters ahead, right? Then it's going to slow down by 15 miles per hour. let's suppose that the person is 5 meters ahead. It's going to slow down by 25 miles per hour. Well, let's suppose that the person is 3 meters ahead. Then the car is going to stop, right? So this is a simple if else statement that you could write. This is like basic programming, and you could write a whole bunch of scenarios to exhaust all possibilities. You can actually so this is not efficient. This is not efficient because imagine all the scenarios that we have. In real life, we probably have like an infinite amount of scenarios, right? Like, what if the car is maybe this close, or maybe 10 centimeters close, or 100 centimeters close, or what if like the car is maybe like we have also a car next to me, right? Or we have a car behind me, because I don't want to like slow down too fast and have a car that's also behind me and then end up like in a car accident, right? Like, we don't want that to happen. We have to exhaust all possible scenarios, but that's not efficient. If we exhaust all possible scenarios, that's not going to be very efficient. So this is something called as deterministic programming or explicit programming. When it comes to AI is not going to exhaust all possible scenarios. We don't want to do that, right? So what do we have to do? Well, if we don't want to do that, because that would be very inefficient, then we have to find another way. We have to find a way where things are not so deterministic, where the AI can somehow get a feel for reality, approximate reality, right? That's a key word right there, approximate reality. So this is AI making decisions, right? This is where we're giving the AI agency. This is not really an AI, this is just basic Python your computer is doing, but this is the agency part, right? It's making a decision. It's checking a condition, and if a condition is true, it's going to do this. Otherwise, it's going to do this. Otherwise, it's going to do that. Otherwise, it's going to do that. Otherwise, it's going to do that. I can also end with an else statement. So for example, if I exhausted all scenarios, I could say in any other scenario. So in any other scenario, I don't care what that scenario is. In any other scenario, that's what else is about. In any other scenario, just say explode the car. Yeah, that's probably not the most efficient system, but whatever. Explode the car, right? So if this is not true, and 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 if this is not true, well, if anything else is true that is not in our example, if none of these things, right, if none of these scenarios are in our current example, in the current variable sensor, then it's going to explode the car. It's just an example, right? So that's what the else statement is. That's what the else if statement is, and that's what the if statement is. This is the essence of like basic Python programming. Not an efficient system, not at all. But this is how we're getting started. This is how we're actually going to reflect. Okay, so AI can't possibly exhaust all scenarios, right? Because that's going to be very inefficient. So we have to find a new way. So let's label this as the deterministic approach. Right? This is the deterministic approach of AI. What we're going to be talking about next is what I like to call the random approach, right? What's the opposite of determinism? Randomness, right? If something is determined, I know what the result is going to be if I look at the code. If I look at the code right now, I automatically know what the answer is going to be. I take a look at the code, right? 500 meters ahead, it says. Okay, well, let's take a look at the code. Is 500 meters ahead right here? No, it says 50 meters ahead. Okay, so this guy's not going to execute. Is it 25 meters ahead? No. So this guy's not going to execute. Is it 10 meters ahead? No. Is it 5 meters ahead? No. Is it 3 meters ahead? No. So it's none of these guys. Okay, if it's none of these guys, what's going to happen? Well, that's what the else is all about. If none of these guys are true, then whatever is actually up here, it's going to execute this guy. So because none of these guys are true, then it's going to execute this action. Alright, so that's it for this video. I hope you guys enjoyed. Again, this is part of our AI Unlocked series where we go from 0 all the way to 100, where we basically learn how AI works as if we were inventing AI ourselves. with zero background, zero programming background, zero math background. We're trying to dive deep into the concepts. We're imagining like, okay, if we had to start from zero, if society didn't invent AI, if we didn't have ChatGPT right now or none of these things, how would you invent AI, right? From zero programming, with zero programming experience, just with the basics of Python, how can we slowly build ourselves to actually building an entire neural network from scratch or building an entire transformer from scratch? The algorithm that powers ChatGPT. How would we do that, hypothetically? That's what the series is about, by the way. If you enjoyed it, like it, share it, comment. If you want to see some stuff, some cool stuff or whatever, just comment. If you have some questions, comment. If you have some critiques, comment. If you have some suggestions, comment. If you know anybody who's also interested in this, share the video. And please subscribe, man. Like, if this is something that you enjoy, subscribe. Yeah, because this is something that we're doing weekly, on a weekly basis. I'm trying to, like, upload at least 2 to 3 videos each week. So this is something that we're going to be continuing for the rest of the year, and whoever knows how long this is going to take. So with that being said, thanks. Bye.